Today, let's talk about basics of logic. So let's talk about what a statement is. A statement is a sentence for which it is meaningful to say it is true or it is false. When a statement is known to be true, it is assigned the truth value T. When it is known to be false, it is assigned to the truth value F. Let's talk about the negation of a statement. Given a statement P, we may have P is true or P is not true. We denote the statement P is not true by not P, and we call it the negation of P. The truth value of not P is very simple. When P is true, not P is false, like this. When P is false, and not P is true. A table that shows different truth values under various possible conditions of statements and relates different statements to each other is called a truth table. So this is a simple example of a truth table. Let's talk about the conjunctions of two statements. Given statements P and Q, we can form the statement P and Q. We denote it by P and Q and call it the conjunction of PQ. Truth table of P and Q is very easy. P and Q is true only when both P and Q are true. In all other cases, P and Q is false. So let's see the table here. When P is true and Q is true, P and Q is definitely true. And for any other cases, as there is at least one F in P, Q. For example, here we have a false in Q, a false in P, a false in Q. So it turns out that the result of P and Q is false. Let's talk about disjunctions of two statements. Given statements P and Q, we can form the statement P or Q. We denote it by P or Q and call it the disjunction of PQ. P or Q is true exactly when at least one of P, Q is true. So here, P is true and Q is true, so P or Q is definitely true because at least one of them is true. And here, the same rule applies. For this row, P is true. For this row, Q is true. So as at least one of them is true, P or Q is true. Both are true here. But when P and Q are both false, P or Q is definitely false. So P or Q is false only when both P and Q are false. Let's talk about conditionals. Given statements P and Q, we may form the statement if P then Q. Denote it by PLQ and call it the conditional from P to Q. P is called the assumption and Q is called the conclusion. Truth table of PLQ is a bit difficult to understand if you hear it the first time. So PLQ is false only when P is true and Q is false. In all other cases, PLQ is true. So the only F here for PLQ is in here. You'll notice that P and Q are both true, then P or LQ is true. And for P are false, then PLQ is true. But notice that when P is true and Q is false, then PLQ is false. From this truth table, we can discover that when P is false, that means when P is false, just notice these two rows, then PLQ is true here. Also notice that when Q is true, that means this row and this row. When Q is true here, then PLQ is true here. So it is natural to ask a question whether the statement PLQ is the same as the statement not P or Q, meaning P is false or Q is true. The answer is yes, and we can verify it using a truth table. That's why a truth table is very useful in relating different statements together. So let's talk about a concept called logically equivalent. Two statements are logically equivalent if they always have the same truth value, meaning they are true under the same conditions and false under the same conditions. So let's take an example. For example, PLQ is logically equivalent to not P or Q since they always have the same truth value under all conditions. So here you can just notice that not P or Q and PLQ both have a sequence of TFTT and TFTT here. So you can notice that they have the same truth values under all conditions. So they are logically equivalent. So now let's talk about the converse of a conditional. Consider the statements PQ and PLQ. QLP is called the converse of PLQ. Notice that QLP is not logically equivalent to PLQ because the sequence here is for the PLQ is TFTT, while the sequence for QLP is TTFT. There is at least one row, for example, the second row, that this one is F and this one is T, so they does not match. So it is not logically equivalent. They are not logically equivalent. Now let's consider a contrapositive of a conditional. Consider the statements PQ and PLQ. Not Q, L, not P is called contrapositive of PLQ. Notice that these two statements are logically equivalent to each other just by showing the truth table of them here. So you can notice that both PLQ and not Q, L, not P have the same pattern TFTT here and TFTT here, so they matches in every row. So they are logically equivalent. So sometimes you may heard somebody say that Q is a necessary condition for P and P is a sufficient condition for Q. What does this mean? That is that if PLQ is true and Q is the consequence or the conclusion, P is the assumption, then you can have these statements. Let's talk about biconditionals. Given two statements PQ, we may form the statement P if and only if Q, or in shorthand PIFFQ. We denote it by PLLQ, and we call it the biconditional from P to Q. So let's talk about the truth table of PLLQ. And this statement is true only when P, Q are both true or both false. In all other cases, PLLQ is false. So let's see here. So for P is true and Q is true, then because the true value are same, so PLLQ is true. So here, as P is false and Q is false, they have the same true value here, and then the PLLQ is true here. So, but in this case, one of them is T and one of them is F for these two rows. So the PLLQ is false. If PLLQ is true, we say that P is a necessary and sufficient condition for Q, and Q is a necessary and sufficient condition for P. This is the end of the video. So if you find my video interesting, please consider subscribing my channel, like my video and comment down below. See you in the next video. Thank you for watching.